Hello, just checking again. Sorry. Audible, right?
Yes, sir, audible.
Sorry. Okay. So in that case, let's get started. So, hello everyone. I'm Sai Venkatakrishnan, a PhD scholar in Department of Computer Science and Engineering at IIT Madras. And this will be our week one NPTEL live session for the course Blockchain and its applications. So, right. So the agenda of the live sessions would be is I'll be either discussing the previous week's assignment questions, which is which you would have been submitted the previous week. So currently week one and week two you are yet to submit. The deadline is 8 February, I guess. So once that deadline is over, the following week I'll be discussing those assignment questions. But for today's session, we'll be discussing, many of you have posted so many queries on the forum. So we will be discussing those questions and looking into the concepts revolving around blockchain, the common misconceptions and all those things. And I will be, one second. You can post your queries in the chat box, or you can post it in the, you can unmute yourself and speak. But I prefer you to post it in the chat box, because if everyone unmutes at the same time, it's going to be a bit of a hurdle for me to manage. So it would be better if you post it in the chat box, right? And yeah, or you can post it in the question Q&A. If you just click on that triangle button in Google Meet, you will get a Q&A option. So you can post your questions over there also. So in that case, let's get started. Okay, so the first question is, I've just copy pasted all the questions that you have asked in the forum, and I'll be explaining those. I'll be answering those. So first question is, I wanted to know the prerequisite for the course and what technologies do I need to brush up. So as far as this course is concerned, right? The thing of with respect to blockchain is it's like an interdisciplinary field, as in it uses concepts from distributed systems. Okay, and it also uses concepts from cryptography and also game theory. So when I mention game theory, is say if you take the notion of this cryptocurrency called Bitcoin, right? So all the parameters that are being used in Bitcoin, as in like how many Bitcoins are there, or like some parameters are there which is specific to Bitcoin. So how they develop all these things is with respect to blockchain is a multitude of these fields coming together, and they are the blockchain is the consensus protocol. Everything is designed, and also the main thing is everything is over networks, right? So networks is base. So if you improve your network latency, right? Because in a blockchain there is no central entity; it's everything is decentralized. So um, if you improve your network latency, it will indirectly improve your blockchain speed also, right? So all these things come into picture. So as far as this course is concerned, just go with the flow. Go through the lectures. If you don't know any concept, just Google it and just brush up on this, because there are so many things. So in blockchain, if you want to get uh, do some research or like more advanced type of studies, right? Depending upon the field you're working in, you can try to incorporate blockchain into that. That's the beauty of blockchain. So say I'm a CS PhD scholar. So for me, and I'm working in security systems, system security. So all this malware and all those things I'm working on. So for me in blockchain, I'd be most interested in how to ensure that someone doesn't corrupt the blockchain or all those security aspects, right? And right, okay. Someone has raised their hand. Yes. Okay, in the Q&A, I got a question whether the recordings of the live session will be posted. Yeah, we'll be posting it in a YouTube channel, and the channel link would be shared to you in the announcements page. So all the live sessions would be recorded, all the 12-week live sessions. So just coming back to the question, right? So being a CS student, I'd be interested in how the blockchain, the actual thing works, like the security concepts and how to make it secure and all those things. For an economics student, they will be interested in the financial aspects of Bitcoin, right? So they'll be trying to come up with any economic policy or something based on Bitcoin. Whereas for say like a management type of background people, they will be able to they will be interested in blockchain mainly because of how it tries to bring in decentralization and come up with new applications, right? All those things. So this blockchain field is like a interdisciplinary field, and you can pick your own domain within that and try to get more interested into that. And this course as such offers you a mostly computer oriented course, and there are like the economic aspects of blockchain. So you would have come across this term called DeFi, right? So these are all like financial applications of blockchain, decentralized finance, all those things. Like this is all based on the cryptocurrencies. So each thing has its own prerequisites if you want to go into depth. As far as this course is concerned, not much of prerequisite. You just have to go through the lectures and Google up if you don't know any particular term. Okay. So in that case, if there are no doubts with respect to this question, I can shall I go to the next question? I'll take that as an yes. So the second question is, why do we need decentralization? So taking the example of say for in the class, professor had discussed about a petroleum consortium, and there are multiple players. Say one is okay, say like player A, B, and C. Okay, and all these A, B, and C are three different entities. Okay, and if I have to maintain a common database or something, right, where everyone can go and update, someone has to be in charge of managing this database, and who will be in charge of this database? If I give this to A, right, if A has to be the single point of like in charge of this database, then everyone B and C has to trust A in maintaining this database. If anything goes wrong with the database, A has to take the blame for, right? A is in charge of that, in charge of the database, and also apart from that, A will have the power, unilateral power, to go and change any details in the database, since A has full control over the database. So in that case, right, in if the database or something, like you have an application, we have multiple players, right? And you might not know the other player fully, or uh, you might know them, but you might not trust them. As in, you might not be willing to give full control over the database or the log to that single leader or the player in charge. So in that case, we need decentralization. As in, every single one of the nodes or the player who is adding elements to the database would be in charge of the database, and they collectively will ensure that the database is not corrupted, or it is being manipulated in a safe way. So this is what decentralization is all about. And also by decentralization, say A is having this copy of the database. If A is the only single leader, then what happens is all your data would be lost if the computers at A or the systems at this A organization goes down. Whereas in a decentralized approach, you have availability, that is, as in like your data is replicated across all the players who are adding to the database, and also everyone are ensuring that the database is correct and it's not corrupted. Any doubts in this question? Why we need decentralization? Okay. So let's move on to the third question. Can we have strong coordination performed using distributed databases? Uh, by V. Vikram. I'm not sure how whether I understood this question. If you're present in the meet, you'll be able to unmute yourself and explain what you meant by this question. I guess Vikram is not there. So let me answer what based on my understanding of the question. Um, the question is asking whether we can use distributed databases in the context of blockchain. Multiple of you have asked the same question, like, can we, is distributed database same as a blockchain? The answer is no. So distributed databases, let's just have a differences table. So at one thing we'll have a distributed database. The other thing is blockchain. Okay. So the first difference is in distributed database, usually say you have nodes present in your nodes distributed everywhere, right? So say like N1, N2 and N3. So three different nodes are there and everyone has a copy of this DB. That's the database. Okay. So in that case, in the context of distributed database, it will usually be centralized. Yes, Sridevi, you have raised your hand. Can you unmute yourself and speak?
Could you please explain again decentralization? I haven't idea about
Okay,
decentralization.
the previous question.
Yeah, yes.
Right. Okay, so say, let me take the example of Bitcoin. Okay, so in Bitcoin is like a cryptocurrency, like a digital cash. So say you have multiple nodes, N1, N2, N3, N4, and N5. Okay, and in Bitcoin, like every node, say N1, N2, N3, all these nodes, right? Each will be having a copy of the blockchain. Okay, so say I represent it like this. Okay, so each will be having a copy of the blockchain. Okay, so this is what, um, and each node should be will be in charge of maintaining its own copy of the blockchain. Okay, and in this setup, usually when you take say, for example, if you take a Google organization, okay, you have your Gmail, right? All your mails should be stored in Google servers. Okay. They will be distributed all over the world, all these servers. Okay. But a single point of in charge would be Google. Google would be taking care of all the servers. All your mails would be stored in these servers. Say something terrible happens, or like as in like the government wants access to your mails or something, or some of your mails are very important, but it gets deleted by mistake, right? So in that case, Google can just go and delete it, or it's since like Google is the only player who is in charge of the server, they have all the permission, they have all the permission rights to just go and corrupt your messages, corrupt your mails, or just destroy your mails, or just deactivate your account. But in a decentralized environment like the Bitcoin technology, right? You have multiple of these nodes, and each will be having this database or this blockchain, and everyone would be coming together to ensure that the copy of that blockchain which every node is storing, right? Say like N1 and N2, each node is storing its own copy of the blockchain, right? So each copy would be the same when compared to the what the other nodes are also storing. So that's what synchronous and decentralization is all about. So in decentralization, the main objective is you don't trust a single node to be in charge of maintaining your database or on all the blockchain. You all the nodes which are participating would be ensuring that your blockchain or the database is correct and it's properly maintained. Did you get the gist of decentralization?
Yes, sir.
So in that case, let me continue my third question, which is the difference between distributed database and blockchain. So in a distributed database, it will usually be a single organization like Microsoft or Google, who would be in charge of all the databases, which is distributed across all the continents, like, right? Whereas in blockchain, it is like decentralized. So decentralized as in like there is no single node which is in charge of the blockchain. All the nodes should be ensuring that the blockchain is proper, its own copy of the blockchain is properly appended and it is in sync with all the other nodes copy of that blockchain. Okay. And the second difference is in a distributed database, usually you will be having a permission setting. Whereas in blockchain, it will be permissionless. Right. So what's the difference between permission and permissionless is that in a permission setting, say you say take the case of having Google, say if Google is there, right? So it is maintaining around 100 servers present in Asia and Europe. Assume it's maintaining so many servers. Now Google is the only organization in charge of its servers, and it will be connecting all those servers into its network, and it will be maintaining all those servers. Now so and it will know the details of every system that it is being connected to the Google infrastructure. Okay, so you can have like say Google is maintaining 100 servers. Google will be maintaining the IP addresses of all those 100 servers. It will be maintaining the configurations and all those things. It will be in control of those servers fully. That is known as permission setting. Okay, and say if you have multiple organizations, say for example take the case of say you want to have a common uh, uh, like a supply chain management, right? So this permission and permissionless applies to blockchain also, but in a distributed database it's always permission. Okay, so a single organization would be in charge or multiple organizations, but the nodes would be predetermined. As in say 100 nodes are there, and every node in that network of 100 nodes would know what the other 99 nodes are. Whereas in a permissionless network, right, nodes can just abruptly join the network and go off. They need not be known a priori to all the other nodes. So that's the second difference between distributed database and blockchain. And the third thing is crucial because okay, The third difference is in a distributed database, the main value is you're providing data as your service. You're storing data and you're, hello?
Sir, I haven't get known about the permissionless and permissioned, sir.
Right. Okay, so if you just take the example of, so in the professor's lecture videos, professor would have explained about this petroleum consortium, right? So you have say Reliance, you have some Indian Oil Corporation, and some other player, say NGC. Okay, so all these three are there. Okay, you know beforehand what the other organizations are. Okay, this, so say this is a network, right? Okay, and each the all the nodes, say assume like these are like node 1, node 2, and node 3. Okay, and each of them knows what the other nodes are. And say if I want to join a new system into this network, I should get permission. So permission as in you will be getting a identity, you will be getting a username and all those things. Once you get that username only, you can come and participate in this organization. So if I just have to add something, you should get a permission, and then only you can go and access in the network. Say I get a permission like AA, right? Your new username would be AA, and only these four nodes can participate in the network. They can be sending messages in this network. Whereas in a permission listing, right, you don't have this boundary actually. Anyone can just join, say some BB or something, any node or any system. Anyone can just join, try sending messages to any other player, any other node, and suddenly they can just go out and they can just switch off their system and just leave the network also. So that's the difference between permissioned and permissionless. Whether you need to get permission before joining the network or not. So did you get the gist of permissioned versus permissionless? Right. Um, okay, I take that as an yes. And continuing with the question, the third difference is in distributed database, the main service is you're storing data, and whenever a user comes and asks, queries the database, you will be responding with the data. Whereas in blockchain, it is not meant to be a data as a service solution. The main aim of blockchain is to infuse trust in your network of nodes. So it's decentralized and everyone is in charge of the database. Everyone would be storing the copy of the database, and they would be maintaining, they'd be ensuring that they maintain a valid copy. They ensure that they are in sync. So, um, so these are the three differences between distributed database and blockchain. Any doubts in this question?
So please explain the third one of blockchain again.
Right. So the third one is, let me just. So the third difference, what I mentioned is in a distributed database, right? The main aim is to maintain your data across different systems, across different databases, different systems, and ensure that data is available at all times. Okay, and the main aim is so that whenever a user queries the database, say um, you are sitting in India and you are querying, you want to get the latest mail. Okay, so the servers might be in India itself or somewhere in Asia, and it will be in sync with other servers in Europe and America. So the main aim is that the data, whichever when you query your database to get the latest mail, that mail should be correct, right? And it should be the latest mail, in fact, and it will be returned to you within this many seconds or something, the latency. And the only thing that the distributed database is uh, ensuring is that you will get the latest data, and it's providing you data, nothing more than that. It's ensuring that the data is available at all time. That's the only thing. So the main service that it is providing is data. You query it, it gives you data back. That's the only thing. Whereas the blockchain is more than that. Sorry. So the blockchain is about trust. As in you are decentralizing it. It the concept of blockchain is it's not like a database. Okay. It does not store the data actually. It stole the hash of data or something, right? But the main aim of blockchain is that, say you have multiple organizations, okay, everything is participating in that blockchain. It is adding, everything maintains a copy of the database in its own system, and everything will be ensuring that all the other nodes in that blockchain would be having that same copy, and no single entity is in charge of the database. So that concept is different from distributed databases. Do you get my? Do you get the gist of the third difference?
Yes, sir. Thank you.
Yeah. Three of them have raised your hands. Devendra Kumar, can you ask your query?
Hello.
Yeah.
Hi, sir. Can you explain again distributive database?
Right. So the distributed database is nothing but you have a database, right? Say you are storing. Let me just erase everything. Okay. So say you have one database over here, okay, and you have some mails being stored, and Google is maintaining it. Instead of having one single database, you will be having multiple such databases, okay. And the main thing is one you will be maintaining it for, like, say you're in India, instead of having the database in America, you will be having in some location closer to India for faster response time and all those things, okay. So now, but all those databases present in, say this is present in India and this is present in America, okay. It's Google's the algorithm thing, right, to ensure that, say I'm sending a mail to someone from X to Y, I'm sending a mail, and that mail gets copied into the database present in India. It's Google's um, role to ensure that this mail is being also present, replicated in all the databases, right? Because data has to be the same in all the databases, the same copy has to be maintained, okay. And this is the notion of distributed databases, and here the single player is just Google alone. It's the central leader and it maintains all these databases. But in a blockchain, you will be working with multiple organizations, okay. And say like you in a blockchain, you don't have a single entity called Google itself. You can just have a blockchain just of sending mails, just like that you can send it, and all those mails will be appended to the blockchain, that immutable log. And there won't be a single organization like Google in charge of that blockchain. All the nodes participating in that blockchain would be in charge. So that's the difference between distributed database and blockchain. Is your question answered?
Yeah, yes, sir. Okay.
Uh,
Won't be such database be very large, because every node will having be the same copy, like
uh,
1 million.
Right, so I have that question later. Someone has asked. Shall I answer at that time?
Fine.
Yeah, thank you.
Hi, sir. Uh,
Yeah,
I ju- at the same point, we just discussed, right, that a blockchain is not the decentralized system. It's not a database, right? It
right,
is just storing. We are just storing the hash of the particular information
right,
there, right?
right,
So, how the actual then where we store the data? If we only store the hash code in a particular blockchain, then we somewhere we have to store the data, right?
right. Okay, so let me mute. Right. So Akshay, interesting question. Let me explain that first. Okay. So before answering Akshay's question, right, let me just give a recap of the terminologies that I'll be using in this live session, right? So I wanted to do this. So, so the first thing is what is called actually consensus. Okay. So what do I mean by consensus is, say you have multiple systems spread across N2 and N3, okay, and each is maintaining its own um, data, right? Some data it's maintaining, okay. So in that case, some data is being maintained, okay, and everything is interconnected, okay. It's connected via some network, and each node can communicate with the others. Now say a user comes, okay, and he is updating this node n1 with some transaction or some data, and node 1 gets updated. Now in this network there is the condition that every node which is maintaining this database, right, db, okay, assume this thing as same is known db database or the data store, okay. So everything should be the same, as in this database, whatever node 1 is being maintaining, should be the same as that of N2s and N3 also, okay. And to ensure that, say the user, if it just goes and updates N1's database, it is up to N1 to ensure that it sends out the updated database. Okay, this one has been added to the database. It should send out the messages to node 2 and node 3, and again everything should sync up, and the same value, say like x equal to 1 is being sent by the user, the same thing should be sent over to N2 and N3 also, okay. And the general terminology what we term this is known as SMR, okay. So this SMR is nothing but state mission replication. So this terminology recap, this whole thing, like about for 10 minutes I'll be explaining. This whole thing is why is that like it will be helpful for you in the next coming weeks of the course also. And the common things that could have been missed out in the lectures, or you will be having slight doubts, those network models or those things, those terminologies I'll just be explaining a little bit so that it will be helpful for me when I later explain, when I answer the questions that you have asked in the forum. There are like 60 questions. So all those answers depend on these terminologies. So it will be better if I introduce these terminologies so that I can answer those questions with respect to these terminologies. It will be more sound, I guess. So slight 10 minutes regress, just cope up with me. So this problem is known as state machine replication, right? So the user is giving some state, it's updating the state at present at the system N1 and the node N1, and that state has to be updated on all the other nodes present in the network. So this is state machine replication, and this thing is what is actually blockchain is also talking about. Okay, so in blockchain, your state is nothing but whatever your the Bitcoin transactions or whatever data is being added, right, to your append only log. So that is what the state is all about, and all the nodes should ensure that the state is uniform. Uh, the same state is being maintained in all the nodes, and that's the responsibility of all the nodes. Now, the second terminology that I want to um, get in is consensus. Okay, so consensus is nothing but user is updating the node 1's state, and this x equal to 1, the state should be updated at all the nodes, and the way it goes and updates the other nodes, it sends out the messages and all those things. Say here n2 would be telling x equal to some other value or something at a later time, and all those things. The way it sends out the messages, and finally all the nodes should either accept this x equal to 1 or should not accept x equal to 1. So that at the end of say 10 seconds, right, or some time t, all the nodes should have the same state. It should all accept, okay, this is the state that I'll be maintaining in my database. These are the data elements. Okay, so that thing is known as the consensus. So like it's arriving to a consensus, all the nodes. And in your lectures, you will be coming across these terms, consensus protocols, all those things. So that's what exactly they are talking about. All the nodes should communicate to all the other nodes, and they should decide on what the updated database is or the updated blockchain is, and this is what is consensus protocol. Okay, the second terminology that we want to introduce is synchronous and asynchronous. Okay. Okay. In a synchronous model, the nodes, if they want to communicate with all the other nodes, right, they will be they can safely assume that the responses, right, will be coming within a set time period, say 10 seconds or something. Okay, so that's what synchronous is all about. It is bound to come within 10 seconds, whereas an asynchronous network, right, in this network of nodes, you cannot know when the response will come back or when you will hear from another node. It can take 10 seconds or it can take 1 hour, it can take 1 day also, but eventually your message will be delivered, but you won't know when it will be delivered. So that is what asynchronous is all about. And why this network model is important is because when you are designing your consensus protocol, okay, when you are designing your consensus protocol, you need to take into account whether the network connecting all these nodes, this network, is synchronous or asynchronous. Okay, based on whether it's synchronous or asynchronous, you should change your consensus protocol, as in the way how these nodes will all come together and decide to get to a common view of the database. All your the consensus protocol, everything will change. So that's why this synchronous model or asynchronous model assumption is important. And usually in real world examples, whatever you are seeing in Bitcoin or Ethereum, they use a model called partial synchronous. And what they assume by telling partial synchronous is, say for some period of time, say like 1 hour, the underlying network will be synchronous. That is, all the nodes can expect the other nodes response within 10 seconds or some fixed time duration. But for the next 30 minutes or so, the network will be in an asynchronous stage. That is like some network outage or something occurred. Okay, so this is the model. All the current blockchains, everything would be uh, using or would be using to design their consensus protocols. And the third terminology that I want to introduce is Byzantine faults. Okay. By Byzantine fault, what I mean is, in this example, you have three different nodes. User is giving some query, okay, and it should be propagated to all the other nodes. If all the nodes are honest, as in like everything is working well, then consensus is not an issue. It's just like a naive solution. Every node talks to the other node, and or you can just select a single leader and like in each round you can elect randomly. You can just trust whatever anyone is giving, and you can just go ahead. But the thing is, say um, right, but the thing is in a real world scenario, n1 might crash, or n1 might be dishonest, as in it might send x equal to 1 to n2, and it will send x equal to 2 to n3. It can send some other malicious data or something. It can just be behaving erroneously. Okay, so to as an umbrella term for all the possible erroneous behavior a node can exhibit in real world, they term it as like a Byzantine fault. Okay, so in a system of, say, if n nodes are present, right, okay, there will usually be um, a condition, okay, and this condition will be like out of the n nodes present in a network, at least at most, right, you can have n by 3 Byzantine nodes. So as in like not more than a third of the nodes can be dishonest or erroneous. So the majority of my nodes, 67% of the nodes in the network should be correctly working and should be honest. Okay, so that's a critical theorem that will be used in many of the blockchain protocols that you will be studying in the upcoming lectures. Okay, so this is one terminology I wanted to introduce, and the second thing is about safety versus liveness. Okay. So what is meant by safety in consensus protocol? If I tell a consensus protocol is having the property, the safety property, what do I mean by that is taking that same example of node 1, node 2 and node 3, right? Say the user is giving x equal to 1, okay? Assume that initially everything is having the same data d, okay? And now the user is giving x equal to 1, and at, after the user gives x equal to 1, after 10 seconds it should either be that this x equal to 1 is added to this data, or the data remains as it is. So all the correctly working nodes in this network should be sure that this they are maintaining that same data in all the nodes. So that's what safety is all about. That is, all my nodes would be having that same data. All these three nodes would be having the same data. That is what safety is all about. When coming to liveness, when this x equal to 1 is given, right, this x equal to 1 should be added to all nodes. That is what liveness is all about. So safety is all about ensuring that all the nodes have the same data, and liveness is about this incoming new data, whatever is being given by the user, it is indeed replicated in all the nodes and is added to the blockchain or the database. Okay, so that is what safety and liveness is about. Yes, someone has raised your hand.
Sir, please explain the liveliness again.
Right. So liveness property is when I'm trying to add a new data, right? It should be the protocol should ensure that this data is indeed added after some time t seconds or something. That is what liveness property is all about. It's not just ensuring. So your consensus protocol, if you take your consensus protocol, okay, it should maintain two things, two key properties it should maintain. One is the safety, that is, it should ensure that all the nodes present in that network will be having the same data. Okay, so say initially at the start of the network, everything is having just a common, just an empty database. Nothing is present in the database. Okay, so by default, everything will be having the same data because everything is empty. Okay, so safety is there. Safety is there. Now a user comes and tells, okay, here update your database x equal to 1 to node n2. Okay, so now node n2 will receive this new data x equal to 1, and what it will do is it will propagate to all the other nodes n1 and n3. Now the consensus protocol should ensure that this x equal to 1 is added to all the databases present in all the nodes. So that is what liveness is all about. It's not just maintaining, ensuring that everything is the same. It should be the case that whatever some new element is to be added, those things are also added within a specified time. So all the incoming requests are also added to the blockchain or the database. So that's what liveness is all about. Do you get it, Mr.? Yeah, Akanksha Bedi, yeah? You have a question?
Yes, sir. Sir, if we want to add something in safety consensus, then how can we do that? I mean, in liveness, you told that it should be visible to all the nodes.
Right.
Then, how in the case of safety?
Yeah, so your consensus protocol should have some voting mechanism or those things to ensure that this x equal to 1 state which the node n2 received, it is propagated to all the other nodes, and everything would be adding that x equal to 1 to its own database. So it's not that simple actually, just sending the data, that new data element to all the other nodes. Say here user 1 would be sending x equal to 1. Here say some user 2 would be sending y equal to 3, or it will be sending say x equal to 5 or something. Okay, so now node n3 will be trying to add its own data into the blockchain, and node n2 would be trying to add its own data to the blockchain. So it is up to that specific consensus protocol. So there are different protocols. Okay, um, like there is the Dolev strong protocol and all those things. And the key thing that every protocol, okay, whatever it is using to break this tie and all those things, like the consensus protocol, it has to ensure that the same data is maintained always among all the honest nodes, the properly working nodes. Those are the non-Byzantine nodes. And liveness is ensured, that is, it should accept the new data and eventually add it to the blockchain or the database. So these two things the consensus protocol has to ensure. Right. Akash, you have a question?
Yes, hi. So my question is related to DLT and blockchain. So distributed lasers, like you have talked about like the centralized system and they are distributed databases. But in DLT, like this, like the database can be distributed and it's not blockchain. Like I think hash graph is one of such technology. I don't know much about it. Like if you can bring little light on that, like how DLT is different to blockchain.
If I've not gone through hash graph or those things, I can go through it and come the next session. But if I recall the hash graph, those things, right, like the blockchain, so like to bring about decentralization, this blockchain is like a data structure, that's it. You can have a hash graph or some other data structure underneath in the same application and still have decentralization and this distributed thing. So
My question was like how DLT is different to blockchain.
ledger, distributed ledger is okay. I guess it is not. I'm not. So I'm not very sure. In my opinion,
Okay, okay.
both are the same as in like it's just some terminologies that we are using differently.
Sorry to interrupt. This is yes. So distributed ledger is a part of blockchain itself.
Okay. And okay, so these are the terminologies that I wanted to just touch upon. One was this safety and liveness, and what is Byzantine fault, and consensus protocol, the state machine replication, and partial synchronous model. Now, coming back to Akshay's question. So, Akshay had asked a question.
Sir, can you please repeat third point?
Sorry.
Can you please repeat third point? Byzantine fault.
Right. Okay. So Byzantine fault is if you have a network of nodes, you can expect any type of failure. Say your power will go off, or say some malfunction in your disk, or your program got corrupted by mistake or something, or wantedly some attacker or someone is controlling that node and sending out erroneous messages. So Byzantine fault is like an umbrella term for all the types of errors that you can expect from your system, all unimaginable errors also. Okay. So that is what Byzantine fault is all about, Byzantine node or Byzantine fault. And in all your consensus protocols and all those things, there will be a condition restricting the number of Byzantine nodes that are allowed in a network. It will usually be the case that the majority of the nodes should be honest and should be correctly working, whereas less than one third of the nodes in the network can be Byzantine. As in it can be erroneous. Is the doubt clear? Right.
Yes, sir.
Okay. So coming back to Akshay's question, Akshay had asked, uh, you have a all those bitcoins and all those things. If the data is not being stored in the actual blockchain, whereas just the hash is being stored, where the other data is being stored, right? Your data can be stored in any other centralized entity, as in a distributed database or some other database also. But what blockchain offers is, say you have this blockchain thing, okay, and say in between you have the hash, and this hash is nothing but hash of some say some your some video file or something. You're hashing this video and you're storing that hash in this blockchain. Okay. and this video you can store it either in your, it can be stored anywhere. It can be stored in those like a distributed database or those torrent databases, right? They are in fact decentralized distributed databases. You can store the video there, but what blockchain provides is, say you're at later time you want to use the video and you are downloading that video from the database. Now how to ensure that your video is not tampered with, it has not been changed. For it, what you can do is you can go and see the hash in your blockchain, hash in the blockchain, and hash the video and see if the hash matches. Okay, so the blockchain as such provides you with the trust that this provides you that a mechanism for you to store the hash safely and ensures that if the video has been changed or something, you can easily figure it out. Yes, someone has raised your hand.
Yeah, can you hear me?
Yeah,
Yeah, hi. Yeah, you said that the actual data is stored in the distributed database.
right,
So, who owns this distributed database?
right. So the actual data can be stored in a normal database or distributed database. It can be stored anywhere. Okay, depends
And the
on your
whole,
use case or application. It can be stored anywhere. It can be stored on your some cloud storage also. It can be stored anywhere. The
the
whole
whole essence, the whole essence of blockchain is decentralizations. It's not a single person. You want to avoid the central entity managing everything.
right,
It's that we are trying to do in a trustless environment. Nobody owns, not a single person owns everything. Everybody owns everything.
right.
The moment you say that video is stored in a distributed database,
Hmm.
the question comes, who owns? Is it owned by everybody or is it owned by some single person?
Right. So if you take the concept of Bitcoin, all the transactions, all those transactions between the various accounts in Bitcoin, everything would be stored as part of the a separate database. Okay, and that will be replicated across all the nodes. And the blockchain will be consisting of the hash of the transactions, as in a block header. Okay, these details would be covered in week 3 lectures, I guess. Okay, and that database would be replicated across the nodes in that Bitcoin protocol. Okay, that is with respect to Bitcoin. But taking the general case of a blockchain, or say if I want to uh, if I want to upload some uh, say uh, say some PDF document I want to upload. Okay, I'm just uploading to Google Drive. Okay, and Google is maintaining that database, everything. Okay, I'm uploading this to G Drive and I'm making the setting as public, as in like anyone can view it, anyone can download and see it. Okay, but how do I ensure that Google or no other entity has tampered with my PDF file? And how to ensure that all the others who are trying to view the PDF who are viewing the PDF, how can they be ensured that this PDF was not tampered with? So for that, an easy way is I can take the hash, okay, of this PDF and store the hash in a blockchain. And the property of blockchain is it cannot be changed, it is immutable. Okay, and by getting the blockchain into this thing, I can make sure that everyone who is viewing that PDF can find out whether the PDF has been tampered with or not independently. So here your question that the blockchain is decentralized, but Google think this the G Drive or something, it is centralized. Yes, it is against the ethics of decentralization. But here you should understand that my aim is not to ensure that the PDF is always available. My aim is to ensure that no one tampers with the PDF, and if anyone tampers with the PDF file, which is stored on Google on the G drive, everyone would be able to identify whether it's tampered or not. And for that, I bring in blockchain. And now this hash, I am not giving it in charge of any single organization like Google or something. I'm storing it in a blockchain and it's decentralized. And I can trust that the hash is correct always. So, do you get my point? Yeah.
Yeah.
Right. Good question, actually, Tushman. So this whole thing is a pretty like ironic. Like as in like you are having a blockchain, you are just having the hash, but the actual file is being stored in a G drive. Then what's the use of blockchain? The actual use of blockchain is to ensure the integrity of the file. Okay, so that's why a common thing in blockchain is like you should not store any say passwords or just like that. You cannot just go and store files or something on the blockchain. You have to hash those things, all those things, and you should store it in the blockchain. And the main aim is to ensure that everyone would be able to identify whether the file is tampered or not, and it gives you a secure location to store that hash. The blockchain provides you with that avenue. Okay.
So if I delete that file, uh, let's
Sorry.
say if I delete that file from Google Drive, and hashes might be stale, right?
Like the hash will be the same. So see,
No,
blockchain
no.
is not about
Hash will
availability.
be stale. Let's say I committed a file in Google Drive,
Okay.
people are accessing, and hash is there in the blockchain. Now I deleted that file,
That,
but block,
that is definitely fine. See, the aim of blockchain is to it is immutable and it ensures the integrity of data. What
but
traveling.
blockchain keeps size in increasing, right? It might contain some stale hash, which may not be
Yeah,
exist.
that is the property of blockchain. So they
No, but does it have mechanism to reclaim these stale hashes?
uh, no, I guess so. Once if something is added to the block as such, it
Because
cannot.
chain is keep on increasing, right?
Yeah, it is
It
append only log.
and actual data is deleted.
Yeah, so this hash is usually just some 256 bits or something. So it don't be much of
256, yeah, 256 bits, yeah,
it varies
yeah.
based on that hash thing. So that's why they store the hash. So like even if it's deleted also, but usually like when you have this type of thing, like you want this PDF to be available always. So that's the thing. You want it to be available always. You can store it in your G drive, or so if the owner of that file wants to delete it, he can go ahead and delete it. Blockchain doesn't stop that. It just gives you
Yeah,
a
yeah. All I was saying that the blockchain chain is keep on increasing.
yeah. It
Some
will
of the
keep on,
entries may not be relevant.
yeah, it will keep on increasing. Good point. Yeah.
Yeah, okay. Yeah, thank you.
So this is way of managing the storage dependencies of this blockchain thing. Okay. So not the actual file would be stored. Instead, just the hash of that files would be stored in the blockchain. Okay. So in this way, the storage dependencies or the necessities that is required across all the nodes, maintaining that blockchain, storing that blockchain would be less, because instead of storing the actual 1 GB file, they just store the 256-bit hash
You
value.
mean the SHA-256 hash?
Yeah, it can be any hashing algorithm. So coming back to the sorry, the forum questions which we were discussing, we have another 40 minutes, so let me speed up with that please. Okay. So question 4 is, can we have few more cases with respect to where blockchain applicability is highlighted? So let me just so one is this cryptocurrency, okay, and the other is you can mention in the lecture supply chain management and all those things. And within cryptocurrency itself, you have like multiple things like DeFi and CBDC. Like CBDC is the digital coin given out by Central Bank of India and all those things. So it's all like central government managed, but those are all digital coins like that. And supply chain and others what I can think of. All those with those smart contracts and all those things. You get ways to exchange like, agreements like property agreements or something. Like the smart contracts and all those things we'll be discussing in the next week live session, because in week 3 and week 4 I guess the smart contracts would be touched upon. I guess it would be better if I discuss the smart contracts. Okay. So there are many uses of blockchain. Sorry, can you mute yourself? So there are many uses of blockchain. The only thing is whether before applying the blockchain to your application or something, you have to first answer whether you really want a decentralized solution or you're good with a centralized solution, right? And blockchain as such, it will have high latencies and all the storage requirements, okay? And only when the need is there to really ensure that you should have a decentralized setup, you should go for this blockchain way. Okay. Yes, Shyam, you have raised your hand.
Can you hear me, sir?
Yeah.
Yeah, sir. My doubt actually, sir, this block actually it contains block header and block data, na, sir?
Yeah.
So in block header, it will be like hash of the transaction and all those things will be there. And in
Yeah.
the block data, that transaction details will be there. Correct, na, sir? So
Okay.
in that, my doubt is, suppose some node is there and
Okay.
they want to access the transaction. How they will access that transaction in that
Okay.
block?
Okay. So, uh,
You got, na, sir?
yeah, yeah. So the in the blockchain, the node thing only will be there, and
Yeah.
okay. So in a case of Bitcoin, right?
Yeah. So in Bitcoin, suppose I'm a node, I want to access the data of the
Okay.
particular block. How I'll access?
So in Bitcoin, the general notation is say F1, F2, F3. There are different types of node participating in a Bitcoin this network. Okay, there are three types. Okay, one are like full nodes. Okay, which are include your full nodes, and the other is like SPV, and other is minor. Okay. So this full nodes would be maintaining all the transaction, all your data, everything it will be maintaining. Okay. So all those things that you are worried about, storage is so high and all those things, these full nodes would be worried about. Okay. There is something called light nodes. Okay. I'm not sure of the terminology, but the concept is these light nodes do not have do not store all the data in the blockchain. They just participate in the blockchain in that Bitcoin thing. They just query these full nodes. They just ask the full nodes, okay, I want this, I want all the transaction details of this particular user ID, like I am the user. I want all the transactions which has been present in the blockchain or something. The full nodes will go through their database and all those things, and it will revert back. So not all the nodes present in the blockchain will have all the data. There will be different types of nodes. Okay, say like me just being a student, I cannot have a such a huge like a server or something and store the blockchain and have so much of storage capacity. If I want Bitcoin or something, I should act as a light node, and I should give these transactions and all those things to the full nodes. They will be storing it on my behalf, and all these consensus protocol, everything among these full nodes, it will occur.
So, sir, thank you, sir, for this. But still one doubt. So,
Yeah,
in case of full nodes also,
yeah,
suppose some five full nodes are there in that case.
right.
So suppose some particular node want to access the transaction of other transaction of a block, how they will access? That is the question.
How they will accept that?
Access the transaction in a suppose a blockchain is there in a one particular block. I
Okay.
am a full node. I want to access the transaction. How I will access?
Okay, so say you're sending some bitcoins to some other account, okay, and you have that much bitcoins left in your purse, okay, and all those uh, details are like, as in like your the transaction that you're sending is valid, as in you're not cheating, you're legally sending bitcoins, okay. When all those conditions are met, then say if you have given that transaction to full node F1, it will add it to the, so as part of just instead of specific bitcoin, explaining it as like a cryptocurrency blockchain thing, like it will add it to the log, and it will send out the transaction details to all the other nodes, and there'll be like some voting procedure and all those things, and finally say after some time period t or something, your transaction would be added to the blockchain and present in all the full nodes, or it won't be added. So there will be communication between all these full nodes. It will be sending out your transaction to all the other nodes. That is what this consensus protocol is all about.
Okay, sir. Thank you, sir. Thank you, and thank you, sir. That lectures were very nice. Actually, so many doubts were cleared.
Oh, thank you.
I was looking for such kind of. Thank you, sir.
Okay. So here when so this question, right, say I have a transaction and whether it will get added or not, that's exactly the liveness property. When you submit a new transaction, it should get added to the blockchain after some time. That is what liveness property is all about. It should get added. Yes, Devendra, you had raised your hand.
Yeah, actually, my question is that suppose I made a transaction in Bitcoin.
Right,
So my transaction got into placed, say, in some block. So
right,
after some time, I would like to fetch my transaction details, and I am not a full node. I know the transaction has value.
right,
So the transaction has will be act as my transaction ID, right?
right.
So using that transaction hash, how can I fetch the transaction data? I mean, my question is basically towards the data structure part. I mean, is may I need to search the entire blockchain starting from the genesis block to the till the date? So
No,
from where,
uh,
which block should I get the transaction?
you need not. So okay, from the data thing. Okay,
So
if you
I
are
hope you
right
got my
now,
point. I know the transaction has, but I don't know in which block it was got minted. So
right.
whether I need to search from Genesis block to the end, or is there any mechanism that I can directly go to that particular block and get the data back from there?
Uh, I'm not very sure for. Uh, so in Bitcoin or those things, like each protocol will have its own optimizations and all those things of storing that underlying actual data in an optimized way, and uh, like say some hash table or something.
Yeah. So
And
if the nodes maintain the hash table
uh,
corresponding to each transaction ID, a block number, then we can there is a direct map and we can fetch the data directly. But is there any such kind of data structure used by the full node? Do you know that thing?
Okay, based on my knowledge of Bitcoin, right, the full nodes would be maintaining something called transaction coins. Okay, so this is actually like somewhat deep into Bitcoin. The gist is it will be maintaining those things, and it will be having the block number also where this transaction was present or something.
Oh,
Um, so these are all like very internals of Bitcoin. So in Bitcoin there is this
okay,
UTXO.
okay, okay.
So this is the
Fine,
key
thanks.
underlying type of that hash store, which all the full nodes will be maintaining. And apart from that,
Sir, please explain DEFI and also CBDC in cryptocurrency.
right. So DeFi is nothing but decentralized finance. Okay. So say you have Bitcoin, right? Or you're transacting using Bitcoin, sending one Bitcoin to the other, and all those things. Everything comes under DeFi. That is decentralized finance. Okay. CBDC is nothing but in Bitcoin, there is no one printing out money, or no one is in charge of that money. As in, like, it's everything is decentralized. Whereas in CBDC, it's like central bank. I'm not sure of this CB full form, but so that,
Central bank digital currencies.
yeah, exactly. So central bank digital currency, digital coins. So in this thing, your central bank is in charge of minting, as in, like, similar to how it mints your physical currencies, right? It will be in charge of the total the currency pool, which is the digital currency pool that it is introducing in that blockchain. So it will be setting in 1 million or 1 million coins or something. So in no, in a Bitcoin, like, no one is in charge, everyone is equal stakeholder. Whereas in CBDC, you have a single in charge entity, like the central government. Yes, it is against the notion of, like, decentralization, those things, but the technology with blockchain and those things enables this CBDC technique. So, like, if it is maintained by the central bank, but everyone can view that blockchain and ensure that no, the currencies are intact and it's not getting corrupted. Yes, someone has raised your hand.
Sir, good evening, sir.
Yeah.
Sir, actually, the notes will be trying to solve a puzzle, no, sir?
Right.
So, and then the one which solves the puzzle initially will be able to add the block.
Yeah, so that is specific with Bitcoin, which is
Yes.
using this proof of work.
Yes, sir.
So why I didn't mention it over
My
here is, yeah.
actually my question is, what is the technical thing that is responsible for a person to add? I mean, a node to add a node to solve a puzzle fastly. Is the compute power? If a node which is having large compute power, will that be solving the puzzle time first?
Uh, yeah, compute power, yes. Yeah, compute power is definitely based on compute power only.
Okay, then the person who is having largest compute power will be the leader all the time.
Uh, no, yeah, the leader can be changing. Yeah, yeah, based on the compute power. Yeah, definitely the frequency of that leader, it can be higher also. The same node getting elected as leader, yes, with larger
So
compute power.
could you please elaborate about how this puzzle solving happens?
Yeah.
Uh,
So in 15 question, that's about something mining. So at that time, shall I explain?
okay, sir. Okay, sir. Thank you.
So moving on to question 5, I think I've answered why blockchain is not a distributed database. And question 6 is also the same. And question 7, whether storage is required or more space. We have discussed this, like, the files are not being stored, whereas the hash is only being stored. Okay. And okay, this thing is okay. Question 8 is nothing but in the professor's lectures, professor would have mentioned you have multiple organizations in the petroleum industry. All will be appending to that blackboard or that bulletin board. They don't trust each other. The question is, then how can you trust the messages? So the thing is, you don't want a blackboard to be corrupted. You don't want to give, you don't trust anyone to give single uh, leadership over that blackboard. That is what professor meant with in respect to trust over there. It's not like you are not trusting the information that they are giving. So say, like, some organization is lying about the petroleum prices or something, it will be added to the blockchain. Later you find out that it is a lie. They cannot step back and tell, hey, I didn't post this information, because in a blockchain it is secure, and whoever posts that information their public identity would also be part of that hash and all those things. So you can easily ensure that malicious organization was the one which posted that information, and it is you can find out those things, right? So you cannot just easily escape after posting a wrong information or something. That is the advantage by using blockchain. Okay. Um, Hope that question is answered. So in that case, question 9, can we call hierarchical hashing as bottom-up hashing? I'm not sure whether I understood this question, but a related term is you would have come across something called the Merkle proofs, okay, or Merkle tree. Okay, so this is something similar, actually same as hierarchical hashing. Okay, so say you have 8 different or some transactions T1, T2, T3, T4. Okay, you have 4 different transactions. Now what do you do to generate a Merkle tree? Okay, first let's see what a Merkle tree is. To generate a Merkle tree, you apply the hash function to the transaction T1. You will get H1, H2 and H3 and then H4. Okay, now again you do hash of these two, H1 and H2, you will get H5, H3 and H4, you will get H6. And again you do a hash, you will get H7. Okay, so this is what a Merkle tree is all about. And in your blockchain, that blockchain which is being maintained in the thing, right, in that Bitcoin, the actual blockchain, this H7 Merkle hash would be stored. Okay, and also this Merkle proof as such, okay, sorry, the Merkle tree as such, this is what is known as the Merkle tree. This will be stored as part of your data across all the full nodes, okay, in the Bitcoin. Let's take the example of Bitcoin itself. So this Merkle tree will be stored. Say some user, he wants to find out whether this say transaction say whether my transaction, this user U2 has posted transaction T2, and he wants to check whether T2 is present in the blockchain or not, and it will go and query the full node. Now what the full node will do is, instead of just replying yes, your transaction T2 is present in block 2, instead of telling that, what it will give back is, it will tell back to the user that your transaction is present in block 2, and here is the Merkle proof. And what the Merkle proof would look like is, it will be like this. Right. So this will be empty. Okay. Uh, so just using the same thing, right? One second. Okay, so what it will give back is, hey, your transaction is present in block 2, and here is the Merkle proof. And it will give a part of this Merkle tree, exactly this part it will give. So this part of the Merkle tree, it will give as a Merkle proof. Okay, so this is what is known as the Merkle proof. And what, as the user, what you can do is, it will give the Merkle proof, as in it will give out this, all these things, like it will give H1, it will give H5, it will give H6, and it will give H7. Okay, now what you can do is, you can hash your transaction H2, you can hash your transaction T2 and get H2, and you can just hash H1 and H2, get H5, hashing H5 and H6, you will get H7. And when you compare H7 with the hash stored in block B2, it will be the same. So that is the proof that the hash, the transaction has been stored in the blockchain. Okay, so instead of just relying on the yes or no reply from the full node as a user. The full node will reply with the Merkle proof, which is nothing but a part of the tree, and also the block number. And and the part of the tree, you can use it to see whether that final this Merkle hash, this H7 is the Merkle tree hash, whether it's same as the one which is being stored in that blockchain. So this is the concept of Merkle proofs or Merkle trees. Any doubts in this? Yeah.
Sir, it means we are not storing the hash of each and every transaction. We just store the Merkle root on the blockchain itself.
Yeah, on the blockchain we are storing the Merkle root only. So it
Okay.
can be like around 10,000 transactions or anything. Instead of storing 10,000 hashes, you will form this Merkle tree and you will store this Merkle
So
hash only.
so while authenticating the any data, right? So that time I need to compute the root, compute the Merkle root again, in which including the hashing of each 10,000 transactions, and compute the final Merkle root and compare the both.
As a user, if you want to see whether your transaction has been added, you need not compute all the 10,000 transaction hashes.
Okay.
That's a very nice question, Akshay. That's the advantage of using a Merkle tree. Okay, so in this case, like if I want to see whether my transaction T2 has been added over here, I did not calculate the hash of H1, H3 or H4, sorry, T1, T3 and T4 to get H1, H3 and H4. The block, that the full node will give me the Merkle proof, the H1 and H6. It will give these three values. Let me use a different. So it will give me this value, this, and this. I can just plug in H2 and use this H1 already given by the full node and get to this Merkle hash. I need not worry about all these things. These things all I need not worry about. T3 and T4 all I need not calculate the hash. I just need to calculate I just need to follow this part alone over here. Starting from H2 reaching back to H7. From H2 to H7. This part alone, what all hashes are there, the hash computation, I should calculate if it's coming correctly and if it's matching that block's Merkle hash, then my transaction is added. Yeah, did you get it, Akshay?
Yes, sir. Yeah.
Okay. So you need not calculate all the 4 transactions and hashes and all those things. So in that case, coming to question 10, question is whether hash function considers space. Yes, it considers the space. Question 11, sir, I didn't understand this function h of mka encrypted with. Okay, so in the video, right, they have used h of mka, and what this means is it is hashing the message, this the message, and this ka is nothing but the public key, and this public key is unique to every user. Okay, so by calculating a hash of this message along with this public key, you will get a unique hash that will identify, that will maintain the integrity of both your message as well as the identity of the user. So say uh, you have the same message, say like some degree certificate or something. It has to be hashed using this public key of the university. Okay, so in that case, whatever hash you get, right, that hash should be unique to that message, plus it is we ensure that that message was being signed or generated by the university alone. No one else can get that same hash value. It will be difficult for them to get because their public key will be different, even though their message is same. So for identity purposes and all those things, right, they use the hash of the public key also together. Not just to ensure that the message is not tampered with, but also to ensure that you receive the message from the user that you are expecting from. You will know the user's public key. You can use that to regenerate the hash and compare it so that you receive that same hash on. So that's what was explained in the video. So let me move to question 12. Someone has asked how the compression function works. Okay, so this thing I refer you to go through the book Cryptography and Network Security by William Stallings. Okay, because these compression functions are a bit involved, like mathematically, and if you are interested, you can go through the hashing function chapters, couple of chapters. So there they would have explained about SHA-256 or SHA-512 very beautifully. So you can go through those chapters and uh, know more about how these compression functions work. The basic idea of these compression function is given a variable input or say not a variable input, say you have some n bit message m. If it's provided to this compression function, it will output a b bits value, and usually this n would be greater than b. So whatever message it's receiving, it is of higher input it's receiving, it is of some higher bit size, but the output is smaller. So that is why the name compression function is used. And in SHA-256 or any algorithm, hashing algorithm, the idea is you give any message, it can be 1 GB file or it can be 1 TB file also. The hash should be the same, that is 256 bit for SHA-256. So it compresses the input and gives out a constant output, right, of the constant size. So that's the essence of the compression function. Roles of input and output, it's pretty direct. So the input is your message and the output is unique value with unique to the message, and is used to ensure that integrity is maintained. So integrity is the main thing with respect to the hash function. So someone has asked which type of data structure is in use for maintaining the blockchain. So the blockchain as such, it's its own data structure, right? You have this hash, right? And you will have another block, and the hash value of this previous blockchain would be also would also be hashed along with the transactions to generate a new hash. So in that case, it's just like a hash chain actually. The previous block's hash should be linked as part of the new block's hash and all those things. So the blockchain is as such its own data structure. It's a new data structure actually. So underneath, for storing the actual data in the full nodes, you will be using multiple techniques like hash tables or key value store. Anything you can be using like binary trees or anything. But this blockchain as such, it's its own that unique data structure. So any doubts in this question? Okay, Prasad.
Sir, what is meant by off chain?
Okay, off chain. Good question. So off chain is something which is not on the blockchain. As in, if I'm correct, say that PDF file example that we looked, right? So those are stored off chain. Only the hash is being stored on in that blockchain, whereas the details and all those things are stored separately. So that's what off chain is all about. It's not stored in the blockchain. It's stored separately, but we'll be storing the hash in the blockchain.
So will that help in saving some memory or something?
Yeah, saving the memory, exactly.
Okay.
You ensure that the file is not being tampered with, even if it's stored in the off chain.
Okay.
because your hash is stored in that blockchain and that blockchain is immutable.
Okay, sir. Okay, sir. Okay.
Uh, Hi, sir.
Yeah.
I just have a question in this same regard. So, in case of Bitcoin only, in the on the blockchain, do we actually store the transaction T1 T2 information, or just we storing the hash of the particular transaction on the blockchain?
We stored at Merkle hash only.
Okay, so the actual transaction information is stored in somewhere other
The
database.
yeah, so it is stored in like a specific database or something, and that database is replicated across all the full nodes of Bitcoin.
Okay.
Sir, what is
So the full nodes contains two databases, the blockchain copy also and the full database copy also.
Yeah, exactly.
Okay.
So this blockchain, why it is being maintained is, say as a Bitcoin user, I may not be maintaining all the data of other transactions, other users' transaction. But if I want to have a efficient way of checking whether my transaction was appended, all those things, this Merkle hash stored in that blockchain is immutable, and it's like an efficient way for me to go and check it. So even if the data is stored in the different full nodes and all those things, right? The hash, they are maintaining the blockchain, yeah. But this blockchain gives you this decentralized trust and all those things. So
Okay.
as far as Bitcoin is concerned, the full nodes are also responsible for storing all these transaction details.
Okay. So at the end of the day there are
Yeah,
two type of databases. One is the blockchain, another is the actual data.
yeah, exactly.
Okay. Yeah. Thank you.
So in that case, yeah. What is mining in blockchain? Okay. So this is an important concept. Okay.
sir, what is longest chain?
Right. Who I have question? Whose question was that?
Longest chain.
Right. So I'll be explaining that longest chain as part of this mining thing. Okay. So in a Bitcoin, right? Bitcoin is a cryptocurrency, and it will have say different full nodes. Okay. Let's just say nodes. Okay. So assume everything is full nodes. Everything has a copy of all the transactions. Okay. So in that case, say some 10,000 transactions are coming to node N1, and what N1 will do is it will create a Merkle hash. Okay, it will create a Merkle hash of all these 10,000 transactions, that a tree type of hierarchical hashing, right? So it will create that Merkle hash and say it is like mh value something. Okay, and now what it will do is it will create a new block, and in this block there will be many fields. One field would be called as the timestamp, okay, like at what time as in a logical clock, as in block number or something, not the actual time or something. It's okay. So the timestamp, and then the block ID and all those things, and then you will be storing your Merkle hash. Okay, and now in Bitcoin, okay, this mining word is specific to Bitcoin, and why they got the term mining is, I'll explain now. When they have to say already some blockchain is present, say B1, B2, B3. Okay, and now I have to add a block B4. B4 has to be added. Now to add, there is one condition that Bitcoin has. What the condition is that you have, say you're following the SHA-256 hashing algorithm. Now what the block Merkle hash should be is that the hash of all these things like mh, appending, so this is the append operator with some random value r, and this will be your block hash. Okay, and this block hash you would be and also this Merkle hash would be having the B3's block hash. Okay, okay. So now this node N1, right? It will find out the Merkle hash of all the transactions. It will combine this Merkle hash with block B3's hash. Okay, it needs to add this new block B4. It will combine this B3's hash with its Merkle hash, and it will get a new hash or something. And now with that new hash, what it should do is, the condition is the final block hash, whatever it gets by appending some random R, the k bits, the first k bits, I guess. So some k is something specified by the algorithm in Bitcoin. Okay, say it is like say 50 or something. K is 50. Okay, so the k, that 50 bits, the first 50 bits should be all zeros. It will have that condition. Okay, so with high probability, okay, so it's like most probably the Merkle hash is whatever you are finding out, right, by appending this B-tree's block hash along with the Merkle hash of all the 10,000 transactions, whatever you are getting, the k, that first k bits of that hash value would not all be zeros. Okay, now the Bitcoin condition to add this block B4 to the blockchain is that it will give the node N1 a challenge. If you want to add a block to the blockchain, you have to solve this challenge. And the challenge is nothing but you have to find a random value R such that when I append that random value with the Merkle hash of these transactions, whatever transactions you got, and this previous block's hash value, you should find an R value such that the total hash value of all these three elements should be such that the first k bits are all zeros. That's the challenge that is given to any node which has to add a block to the blockchain. So this first k bits 0 is the puzzle, the cryptographic puzzle or the cryptographic challenge. Okay, and you might ask, okay, like what's the difficulty in getting these first k bits as 0? Can they just use some analysis techniques or something like that to get the first k bits to be 0? The answer is no. The thing is, you should use a strong hashing algorithm. It depends on your hashing algorithm, and the thing is, like, if you want to find if you want to say for like SHA-256 having like 256 bits of that hash value, right, to have the first k bits to be 0 or something, you should at least go through 2 power 50 iterations. First 50 bits to be 0, you should at least go through 2 power 50 iterations on the average to find out like 2 power 50 iterations of different random values, this R value. You should try out to see whether the first 50 bits are 0 or not. Okay, luckily you might find that you might find a random value in the second iteration itself or in the fifth iteration, but on the average, like based on probability, right, whether on average you should go through 2 power 50 iterations to find out these k bits are 0 or not. And once you find that R, then you create a block and you send that block to all the other nodes, and the other nodes will see whether you have solved that puzzle or not. So by solving the puzzle, as in you will send out that random value R, you will send out your Merkle hash, as well as you will send out your the block details and all those things. Now all the other nodes, what they will just do is they will just see whether this puzzle is being solved, whether appending the R value with the Merkle hash and finding the that overall hash value has the first k bits or that 50 bits to be 0 or not. If it's a 0, then yes, you have solved the puzzle, and the other nodes can go ahead and add your block that you are advertised to its blockchain copy. Okay, so this is what this cryptographic puzzle is all about. And coming for mining, what is mining in this case is, since your node N1 is using so much of compute power to ensure that these transactions are getting added to the block and ensuring that puzzle is being solved, like so much of power consumption and all those things, what the Bitcoin will do is it will mint new coins, as in how your bank RBI just prints new currency, right? It will create new digital coins. Okay, it will create new digital coins and give it to node 1. So node 1, say, is running by me. It will give it will give those coins to me and I get those coins. So that is like a reward that I am getting for solving this puzzle. And since I am just creating these coins out of nowhere, right? I'm just creating it. I'm like not creating as in like the overall. So the as this node N1, when it's creating the block, when it's creating that block and appending it, it gets that reward, and those coins are just created from the algorithm, those digital coins. And for that they use the term mining. The node N1 is mining and it creates new coins, and this node N1, whichever is adding that block, is termed as a miner. Okay,
How
Sir, if two people coincide that same time they get that puzzle solved, then who will be given a priority?
right. Good question. So that's where the longest chain protocol comes. So say now if I have both uh, node N1 is telling this B1, B2 is there, and now both N1 is also telling some new block B4, and N2 is also telling a new block B4 prime. Okay, assume that, and transactions might be overlapping or something like that. Now for some set of nodes, say like let's partition all the nodes, right? Some nodes which will be which will be receiving N1's block B4, they will add B4 to B3. Okay, say N1 till N1 and all the odd number nodes N1, N3, N5, like that. All the nodes are being uh, all. Let me just change the numbering. Say like totally 100 nodes are there. Okay, and from N1 from N1 till N60, say they accept B4, whereas from N61 to N100 they get B4 prime. Okay, so from N1 to N60 they will be having this view of the blockchain where B4 is the last block which is added, whereas for N61 to N100 they will be having the same blockchain, that is this B1, B3, all those things will be same, but instead of seeing B4 as the last block, they will be having B4 prime. Okay, so in case of at the same time different nodes are giving out different blocks, what will happen in that case is, say after some time period t, say some 1 hour or something, like what happens is some nodes in this if you notice over here, only 40 nodes, okay, have been know that B4 prime is the latest block. Whereas over here, 60 nodes know that B4 is the latest block.
Sir,
Okay.
how did this segregation happen, sir? This N1 to N60, N61 to N100. What is that?
Right.
Accept.
So as in like, okay, coming from starting, right? So like, say your node 1 forms a new block B4 and it sends out to all the other nodes. And the other some node N61, okay, say it sends out block B4 prime, a new block, and both of them are trying to add after B3 only. And
No, both of them will be sending this B4 and B4 prime to the all the nodes, no, sir?
yeah, so they will be sending to all the nodes, okay. But assume that due to some network delay or something, okay, the network got partitioned, as in like N1 sent its messages to all the nodes, but N61 to N100 didn't receive that message. Okay, so in that case, what happens is all those 40 nodes, whatever the N61 could communicate with, they will all come to the conclusion that okay, B4 prime is the latest block, and they'll just add it to the blockchain.
But
Whereas,
but they might also be having the data that is being received from N1 also, no, sir? B4 also they might be having.
yeah, just assume that they didn't receive N1's message.
Okay.
Okay, so at that case, what happens is they can receive it later or they can receive it after some time. Just assume that due to some network delay or something. Okay, or you can assume like that intermediary nodes which are sending out these, relaying these messages are not sending it properly. Some network delay or something. And what happens is these 40 nodes would be storing B4 prime, and the 60 nodes which received N1's message would be appending B4. And this is what is known as a fork. Your blockchain is getting forked, as in split into multiple chains. One chain is this B4 as the latest one, and the other chain is B4 prime as the latest one. And what happens is, say after some time, after say 1 hour or something, this network delay gets erased, and now everything is set properly. Now N1, N60, everything can propagate messages. Within this 1 hour, what would have happened is these 60 nodes would have added, say, other blocks like B5, B6 or something. And this, let me just. So A1, B2. Okay, so this N1 to N60 would be having this block, whereas your N or remaining 40 nodes would be storing this thing. Okay, so at the end of say this fork happened, and after say some um, so initially due to some network delay, this B4 gets added by these 60 nodes, and the remaining 40 nodes at B4 prime, and that network delay persists say for 1 hour or something, and these 60 nodes keep on adding blocks to these on top of B4. So they have added B5, B6 and B7, and these 40 nodes they have added to B4 prime, and on top of B4 prime they have added B5 prime also. Okay, so and after 1 hour, now that network delay is all over, and now all the 100 nodes can communicate with each other freely and smoothly. Now what happens is, now everyone would be trying, say now node N1 again wants to add a new block which is called B8, right? When it tries to now add a new block B8, it will now be sending B8 to all the other nodes, all the remaining 100 nodes. And at times, what the other nodes would also be receiving is, what is the latest length of the blockchain? Okay, so these 40 nodes should be having the length of blockchain as 5, whereas the 60 nodes should be having length of blockchain as 7. Now when this 40 nodes receive from the neighboring these 60 nodes that the blockchain length is 7 and not 5, then it means that these 40 nodes had been in the dark and they didn't know that the, the blockchain has been appended by the majority of the nodes. Okay, so in that case, what they will do is they will just remove these blocks B4 and B5 prime, and all these 40 nodes would just maintain this blockchain up to B7, this original blockchain which was being maintained by the majority of the nodes. And they will start adding blocks to this B7 and all these things. So they will just do a sync up of the blockchain, the block length, and whichever length, right? So here N61, these 40 nodes was maintaining this fork actually, and the length of this fork was actually 5. When compared to the other fork, which was 7, it is smaller. So the default protocol is whichever is the longest chain in this fork. So B1 to B7 is the longest chain, not B5 prime. So all the nodes will then just use the longest chain, that is B7. So that is why the other name, the protocol which Bitcoin uses is known as longest chain.
Sir, one thing, like how do you determine like those two nodes got added, okay, initially, but got removed?
How do you determine?
Like
Okay.
actually the nodes got added, na, but the chain determined that if we add these two nodes, the chain won't be a longest chain. So the you added those nodes, you just remove those two nodes.
Okay. What's your question?
So like in blockchain the integrity of each node is defined, like but like each nodes, once a node is added, you just can't remove that node.
Right. Okay. So yeah. So that is so a good question. That is known as blockchain finality. Okay. And what this blockchain finality means is, say I am you're the seller and I am the buyer. I am buying a car from you. Okay, I am sending you some say 1,000 bitcoins, and you should give me the car. What I will be doing is I'll be submitting the transaction to a full node. It will be say the transaction is part of this block B4. Okay, this B4 prime. So this transaction is part of this block B4 prime. And now what happens is I see that I just query one full node, and that full node happens to be something within these 40 nodes, this N61 to N100, and it returns that yes, your transaction of 1,000 coins is there in this block B4 prime. And on seeing that, what you do is you just send me the car. But later at some point of time, all those after this longest chain is all the nodes again communicate with each other, and the longest chain is confirmed as B1 to B7, and this B4 prime is removed. Like that transaction, whatever I had sent you, that 1,000 bitcoins is not part of the blockchain. Some other full node has to take up those removed transactions and again add it to the blockchain uh, at the end of B7, say in block B8. Okay, so in that case, your question is, how will I know that you are telling the blockchain is immutable, but because of these forking, like because two different nodes at the same time, they are trying to add to this block B3, appending to block B3, and it got forked into B4 and B4 prime. So this is chain 1 and this is chain 2. So because of this forking, my B4 prime got deleted at a later stage. So how is this immutable, you are asking? To ensure that this is immutable, say like as a seller, what you should do is, you should not immediately give the car to me. You should not sell the car to me just in seeing that transaction is part of B4 prime alone. What you should do is, you should see that some at least 10 blocks, or there is a parameter like at least k blocks have been added on top of this B4 prime. And once that is added, with 99% surety, you can give me the car, and you can be sure enough that that block won't be removed at a later stage also.
Got it. One more thing, like how do you in the above like slide you mentioned that k bits we have to make zero. Okay, that was the puzzle. So
Ah.
how determine how, like what will be the k value? Like
Right.
like
So, good question again. That K would be determined as part of the protocol. So, every full node would be running the Bitcoin program within it. And that Bitcoin program has a condition that I'm not very sure how. So, that Bitcoin condition is like every 10 minutes, one block should be added. Something like this, if I'm correct. 10 minutes or then assume that like it has a condition
every
that
10 minutes
yeah,
every, yeah.
so every 10 minutes a block should be added. Now say your compute power got increased such that you are able to add a block within 5 minutes itself. Okay, the last 100 blocks were added, each block was added within 5 minutes. Then what the algorithm will do is, it will automatically increase the value of k such that more number of bits should be 0. So it will increase the complexity of the puzzle. So if more number of bits are 0 means, say instead of 50, 100 bits should be 0. Now on average you should go through 2 power 100 iterations. So to uh, go through those 2 per 100 iterations, you will take again 10 minutes or something. So based on that average time a block needs to get added to the blockchain, right? It will be that k value will be changing, and the k value will be changed to ensure that this 10 minutes per block is that this time period is maintained. The puzzle is not too easy, not too difficult.
But it means like it will be adjusted according to,
Yeah,
like if
exactly.
you increase the computation power, then also like the puzzle
Sir,
will
can
still
you
be
explain
difficult.
the types of hashing?
Right, it will be adjusting it.
Got it.
Sir, can you explain the types of hashing?
Types of hashing.
Yes, sir.
Uh, I guess types of hashing is explained in the video lectures. Do you go through the lectures?
And here again, like like for each node, if we add each block we add,
Right.
we will get one coin. Or like how determine like how many coins will I get? Like will it is the time I spend for the computation, or like how do you determine like, or the block lengths kitne coins will like we will get?
That is also determined by the algorithm. So currently it is like 8 coins or something, and as time goes, it is keeps on reducing.
Got it.
Right. Muskan, mostly for another 10 minutes or so, I'll be continuing this meeting. That's it. Sorry for the delay. Since it's first session and it's been like 2 weeks of the video lectures, right? There were many doubts, so I had to take my time to go through this.
Sir, it would be good if you could show us some demo like for this thing. Is that possible?
As the demo, they would be showing it in the video lectures itself uh, as part of Ethereum blockchain, I guess. So at that peak, I can try showing a demo during that week.
Okay, sir. Okay.
Okay. So coming back to this longest chain consensus, this is what this longest chain is all about. And this blockchain finality is nothing but you should your transaction is committed to a blockchain only if some number of blocks gets added on top of that block. Then only you can be sure that no other chain is being constructed. And the reason being that say some k blocks have been added on top of that, say some 10 blocks have been added on top of that blockchain, on top of that last block of your transaction, say B4 or B4 prime. You can be sure that all the remaining nodes, okay, they don't want to be wasting their compute power on trying to form a new longest chain, okay. Instead they will just try to append to the, the longest chain or the already longest chain. So that's why there is a condition in Bitcoin that the majority of the thing should be majority hash power, that is more than 50% of the compute power should be honest. They should not be as in they should not be malicious. So if majority of the compute power is malicious, what happens is they can just create a new chain starting from the first block and they can create a new longest chain. Any doubts in this?
Sir, what do you mean by compute power?
So compute power as in like um, they are they are solving these puzzles, right? So the 50%, say like 100 nodes are there, okay. It's not that 50% of the nodes should be honest, it's 50% of their compute power should be honest, as in like just 3 nodes put together may be more than say a bulk of computational power they have. Those 3 nodes should be honest, importantly,
Okay.
for me, right? So since
Sir,
everything,
suppose a person wants to join. Sir,
yeah.
suppose a person will join in blockchain, in a blockchain. He wants to transact through blockchain. So he'll become a node, no, sir?
Yeah, he will become a node. Wait. So
He'll become a node.
Say in Bitcoin, if I want to
Yeah.
send some Bitcoins to you, you need not become a
Yeah.
node. You can just, you should have
Okay.
a public key and private key that like it acts as
Okay.
your account number. And you will be just sending
Okay, sir.
your transaction, that Bitcoin thing, you will be sending a script, so that thing would be discussed in week 3, I guess. You will be sending it, the full node
Okay.
will take that input and add it to the block. You need not have a node, you can just
My
have a laptop. That's, you need
Yes,
not
sir. My
run the
question is
Bitcoin.
the RAM of my laptop is the compute power, right, no, sir?
No, the compute power is with respect to the full nodes, not individual users. The full nodes which are
Okay.
maintaining this blockchain, adding blocks to the blockchain, that compute power should be more than
Okay.
50%.
Okay. Then what do you mean by these puzzles? Who will be solving these puzzles, sir?
The miners, so the miners are
Yeah.
the type of full nodes who will be adding new blocks.
Okay. That means a person who is in the blockchain as a node can't be a miner.
Up, can you come again? Sorry.
So, sir, suppose I am a part of the blockchain.
Right.
I am transacting through blockchain.
Uh,
Uh, can't I be a miner?
you can definitely be a miner. You should have that compute power. It will be so much of power consumption and all those things. You can be a
Then
miner.
who will decide? Who will decide, sir?
Exactly. So it's Bitcoin is a permissionless network. You can join the
Yeah.
network anytime you want. You can leave the network.
Okay.
The only assumption it has is more than 50% of the compute power should be honest.
Okay.
That's the only assumption. And that's the beauty with Bitcoin, because it doesn't place a gateway or something to filter out participants who want to join the network. If you have a laptop, if you have a server, you can just
Yes, sir.
download the Bitcoin code and join the
Okay.
network, start acting as a miner.
Okay. Okay. Okay, sir. Thank you.
Right. Uh, okay. In that case, I guess it's time actually. The 2 hour session has ended. One student had asked about types of hashing. I suggest you go through the video lecture in week 2 or week 1, I guess. The professor would have explained the hashing concepts really well. If you have any doubts, try to ping it on the forum. I have other questions to discuss also, but in want of time, maybe in the next
Sir, can you please suggest a blockchain platform which uses Python, sir?
I'm not very sure of those things. Maybe I can. You can just Google it actually. So I'll just end this session with question 16. Someone had asked which programming language does blockchain technology use? So there are two things when coming to like programming and blockchain. One is your core, the consensus protocol, as in that Bitcoin algorithm itself or something. That will be in C++ or something. And the other is the smart contract which are on the chain itself. And the smart contracts usually would be something very specific, not like a general programming language, but with each blockchain type like Bitcoin, Ethereum, the programming languages, those things will be changing, so it is very specific to that blockchain. So mainly as end users you will be interested in smart contracts, and there are multitude of languages supporting these, and it depends on the blockchain that you want to use. Right. So in that case, I guess let's wrap up the live session for now. The remaining questions I will answer it in the next session. Um, I'll answer those questions first, and then we'll continue with the that weekly's questions and those things.
So recordings will be shared, sir, so
Yeah.
that we can remember.
Yeah, sure. Recordings I'll be uploading it by today or tomorrow on the YouTube channel, and I will be sharing the link also. The NPTEL admins will be sharing the YouTube channel link, so you can view those. View those.
So thank you, sir. It was excellent, sir. Today we came to know more thing about blockchain. Only we knew the basic things.
Thank you so much. My pleasure. I'll try to answer the remaining questions in the next session for sure. Since this the first live session, I expected it to be like crossing time, so like as expected, because you would have been having 2 weeks of doubts piled up. So but most of the other questions are also related to the same thing, as in the longest chain or consensus and those things. The only thing that I didn't thought of explaining, but I don't have time now, is the birthday paradox, which you can refer in the cryptography and network security book, which I'll just have a brief uh, thing on the next session.
Sir, can you explain the consensus protocol once?
Okay. Consensus protocol is nothing but it should ensure that all the nodes present in that participating in the blockchain have that same view of the blockchain, and also it should ensure that any new item you are adding to the blockchain is eventually added. It's not stale, it should be added. This is what consensus protocol is all about. It should all get together and decide on, okay, this is the blockchain that should be same among all the nodes. In simple words, that's two of them have raised their hands. Muskan.
Sir, actually, I have joined this course today. Can you please guide a little bit about this?
No, nothing much. You just have to go through the video lectures, and if any new terminology you come across, just Google it. There are many explanations which are really like simple enough for you to have a head start. So you can just Google it and or um, find out, uh, get understanding, because these video lectures, at least for the first 2 weeks, are not very in depth. So you can just start watching it. Um,
Any recommended books for this?
uh, no, it this is like an interdisciplinary field. The lectures are the best way to get into the video lectures, whatever NPTEL has released. See, like whatever topics that I have discussed, like consensus protocol, safety, and liveness, I looked at the NPTEL lectures, and the other I had browsed through the net and gone through white papers and those things to gain knowledge. So start going through the NPTEL lectures, and once you get in sync with those terminologies little bit, right, you will you can easily Google it and find many good articles explaining about these terminologies in depth. There are plenty of articles you
Sir,
can.
when the exam will be conducted for the blockchain?
I suggest you just look at the NPTEL page. I'm not sure of the dates. I think the enrollment will end in 2 weeks also, the exam enrollment. So I suggest you go and see in the NPTEL page.
So can you share your YouTube channel name where you will upload this recording?
Yeah, yeah, this recording I'll be uploading on YouTube.
Okay, sir. Okay. So can you share the your YouTube channel name?
Sorry? Oh,
Hello.
yeah, yeah, that link I'll be sharing it. I have not created a channel. I'll be sharing it.
Okay, sir. Okay. Thank you, sir.
Yeah.
Can you please take a look at question number 1 of assignment 2? I think it's a bit unclear whether Bob is sending the message to Alice or Alice is sending the message to Bob. Can you please just take a look to question number 1 of assignment 2?
Don't. Question number 1. Can you just share yours? That question. It's like a typo mistake or. Oh, assignment
Actually,
2,
is
right. Oh, assignment 2, question 1. Yeah, many of you have raised an issue like that encryption or decryption is not mentioned,
yeah,
right?
yeah.
Uh,
Also, who is the message sender? It's not getting clear whether it's Alice sent to Bob or Bob sends to Alice.
I have sent a mail to the course TAs who are setting the questions for the assignment. Actually, I am the live
Oh,
session TA, so they'll be updating the question. Or if not, that if there is a typo mistake or something, don't worry about the marks. It will, if you mail NPTEL or something regarding this discrepancy, they will neglect that question also, if there is a mistake or something.
Can you tell about the difficulty level of this course, like compared to other cryptographic courses, or like?
Okay, first thing, this is not a cryptography course, because cryptography you will go in detail about the mathematical concepts behind the hash functions, digital signatures, etc. Here you assume that you know about these hashing and signatures, the basic concept, and in detail in the coming lectures we will be discussing about a permissioned blockchain and a permissionless blockchain. So Ethereum, Bitcoin, Hyperledger, and other things we will be discussing. So if you want a very nice overview of the current state of the art blockchain technologies, like blockchain is itself a recent field. So if you want to get an overview, then definitely this is a nice course. It's worth putting in your effort and try to complete the course.
It will be like other IT Madras courses, like difficulty level, like matlab,
I'm not sure what your question is.
like the usually IT Madras courses final exams are tough. Okay, so like I wanted to ask, like, because it deals in recent technologies, so
No,
questions will be like theoretical, like, or what type of questions would we be
the
asked?
questions, no, I've not looked at the questions, but it should be straightforward. Or see, if the questions are critical, right, then definitely whatever mark you get is worth enough. You can put it in your resume and brag about actually. So if you should understand the concept. That's it. If you understand the lecture and the concepts, right, um, it should be straightforward. Not at the level of whatever is written IIT Madras. Those will be like analytical and those things like programming and those things. So this is NPTEL course. That's it.
Got it. Thanks.
Sir, will the problems be asked in the exam?
I'm not sure how the exam final will be done, but final exam pattern, it will be mostly MCQ or some subjective type question, but it should be straightforward. Whatever is covered in the lectures only will be asked, not something outside.
Okay, sir.
Right. Um, if no other questions, then I'll take leave now. Um we'll see you all in the next week, same time, Saturday, 3 p.m. The same meeting.
Okay, thank you, sir.
Yeah. Thank you everyone for joining.
Thank you, sir.
Thank you, sir.
Thank you.